right, let's get into our second one. So for this part here, we will be a little bit more efficient. Let's do that in our first video. We made a table first, and you can always make a table. You choose how you'd like to do this to parameterize these curves. So instead of making a table first, let's use a little bit of logic, and let's do the last part we did, where we want to get rid of all the t's. We're still going to need to look at them, but we want to choose. Do we want to go with, can we solve this one for t easy? Or this one for t easier? And hopefully you're saying, well, one has a square, so don't mess with that one. Mess with the one that doesn't have a square. So let's go to the x, and let's just subtract over our 2, and we find that t is indeed equal to x minus 2. Once we have this, we just plug it in for t. See, this is not that bad. For everything you've been doing, the hell I've put you through, it isn't so bad. Now we take our x minus 2 and we pop it in. Now, hopefully y'all don't have to actually like foil this thing out by like, all right, first, outer, inner, last. You just know x squared, those two things with a 2 in front of it. So 4x, and then just square the last part. Here we go. Let's combine like terms and see what's up. So, oh shoot, it's a parabola facing up. Neat. Weird, it's a parabola with a square that started, but hey, happens. You're gonna miss these once we go a little further into it, because of course it's gonna pick up steam. It's gonna get a little tougher, but if you're gaining this, you're good. So now that we have this, well, dude, I can sketch a curve of this. Right? I mean, shoot, this thing even factors. Well, come on, dude. So it looks like we have at 5 and at -1, we have zeros, right? That's where we hit our x-intercept. Oh, shoot, that's a -5 down here. That's our y-intercept, so it looks like our curve is going to do a little something like this. I mean, we could find the bottom part. I actually need to get those arrows off of there, because we're going to go in a certain direction. So we sketched it. We graphed it. We know what's up. Cool. Well, let's get rid of everything because we're not done. We sketched a parabola, but we have to give it direction. We're going to have what's called a positive orientation. So we need to know, where do we start? Where do we go? So start with your x and see which direction are we going. Like, let's plug in t equals 0. So we're going to get 0 plus 2 is equal to our 2. So let's say that we start here. Now, all we're looking for is, we're going to go left or right. Are we going to go left or right when you plug in t equals 1? And now you have 1 plus 2, which is equal to 3. So it's saying, oh, we're moving this direction. As we add more t's, it's telling us, nope, this is the direction of the curve. This is our positive orientation. So when you sketch curves, it's not as much about just drawing the curve. You have to give it orientation. Now, this is going to be a little rough because a lot of us are doing this online homework crap. It's not a very good spot to learn how to graph. But do your best. All right, let's go to another one. Oh, I love this one. Now, this doesn't work out quite as well, so you want to pay attention. Anytime you see trig, there's a trick to this. I don't want to start plugging in inverse cosines into stuff. There's going to be a trick to parameterize this. Or actually, I'm saying that backwards. But let's go. So we want to get rid of our t's. But how the heck do we get rid of our t's? I mean, hitting both sides and saying cosine inverse of x is equal to t, and then popping it in here and going, well, y equals sine of cosine inverse of x. So, all right, sketch it up, dude. Just sketch it up for me real quick. Yeah, I don't know what that freaking stuff looks like either. Lies. But there's got to be a better way. And here it comes. Here it comes. Did you know cosine squared plus sine squared is indeed equal to 1? That is the trick for trig. This is the trick. You got to know it. You got to know it. This one doesn't work out as nice. Oh, I just solved for t and I plug it in. Nope, doesn't work that same way. The way we're going to parameterize this is we said, oh, it's cosine squared plus sine squared is equal to 1. But there's cosine of t. Replace it with x. There's sine. Replace it with y. So the equation we ended up getting was x squared plus y squared is indeed equal to 1. It's a frickin' circle. It's the unit circle. It's not just a circle. It's the circle. It's the unit. Wow. I can't draw a straight line to save my life. Not a terrible circle, but it's a circle, right? We know that. You all took trig, and I messed with you enough, so there's our curve. Oh, but what direction does it go? Now, this is where your teacher will get tricky with you, where I want to see, like, can you tell which direction it goes? So I throw a negative on the cosine, things might change. I throw a negative on the sine, things might change, but we'd still end up with the same result. So let's go back. We found our stuff. So the way that I figure out the orientation is I just want to know what's going to happen to the x. Oh, but we have to look at the y in this one too. It's not a function. Dang it. So let's put in t equals 0, just so we can figure out where do we start. So we're going to plug in cosine of 0, cosine of 0, cosine of 0. That's 1. Sine of 0. That's 0. Cool. Let's go to another value. Well, don't plug in 1. Do you know cosine of 1? I don't either. I want to go with pi over 2. Let's see what happens when we plug in pi over 2, right? Because we're dealing with trig functions. So cosine of pi over 2 is clearly equal to 0. And sine of pi over 2 is equal to 1. So our first point was here where t equals 0. When t equals positive pi over 2, we're here. Oh, we're moving in the positive rate. Hey, it's just like the unit circle. How we go through quadrant 1, then quadrant 2, then quadrant 3, then quadrant 4. There it is. And this is how we're going to deal with our trig functions. Now to go back. Now your textbook does a lot of writing like this. Where, here's the end. I'll shut up in just a second. Where we could say x equals cosine of t, but we could also say that this is f of t. Same thing over on the other side. We could say, well, y, well, this is g of t. And they're going to use a lot of notation like that. So you can choose as to whether you use your x or your y. But just make certain. They just use it a lot. I want to make certain we touched on that because the textbook I work from doesn't use a lot of that. And there it is. Parametrics. Cool. I will see you in the next video.